We're told an isosceles triangle with two of its sides as 8 centimeters sits inside a sector with a radius of 11 centimeters and a central angle of 120 degrees. What is the area of the shaded region? Either enter an exact answer in terms of pi or round to the nearest integer. So pause this video, have a go at it before we do this together. All right, now to do this, we just have to figure out the area of this sector of the circle and then subtract out the area of this triangle. So let's first figure out the area of this sector of the circle. So we know that the area of the entire circle, I could draw that better. The area of the entire circle, if we were to go all the way around, is pi r squared. So that would be pi times 11 centimeters squared. So that would be equal to 121 pi. This would be the entire, that would be the area of the entire circle. Now, if we just wanted this sector, and that would be even including this, we're going to subtract out the area of that triangle in a second. Well, we just have to figure out what fraction of the total area is it going to be? Well, we have a central angle of 120 degrees. So the fraction of the entire circle, it's 120 degrees over 360 degrees. If we had the whole circle, we would go all the way 360. So 120 over 360 is essentially 1/3. And so this is going to be 121 over 3 pi, or we could even say 121 pi over 3 square centimeters is the area of this whole sector. Now we have to figure out the area of this triangle. And let me draw it a little bit differently here just to make it hopefully a little bit clearer what's going on. So we know that it's isosceles. So that length is 8, that length is 8. We know that this angle right over here is 120 degrees, 120. But if we were to drop a perpendicular right over here, that would bisect this angle because we are dealing, and it would also bisect the other side there because we're dealing with an isosceles triangle. It's now symmetric. And so this would be 60 degrees. This would be 60 degrees. And how would we figure out this length? Well, you might be familiar with 30, 60, 90 triangles. In 30, 60, 90 triangles, and that's what's here. We have 60, 90. This angle right over here is going to be 30 degrees. And so in 30, 60, 90 triangles, you have the opposite side of the 30 degree is going to be half the hypotenuse. So this length over here is going to be 4. That's half of 8. That's 4 right over here, that height. And then this side over here is square root of 3 times the short side. So this over here is going to be square root of 3 times 4. Now, if you want the area of the entire triangle, you just have to multiply 1/2 times base times height. So that's going to be 1/2 times the base is going to be 2 times this, because we have this whole thing right over here for the entire base. So 2 times 4 square roots of 3. I should have written that like that here. 4 square roots of 3. It's a more natural way of writing it. Times the height, times 4. Well, these two cancel out, and we end up with 16 square roots of 3. 16 square roots of 3 is the area of this triangle right over here. And so if I want the area of just the shaded region, it would be 121 pi over 3 minus 16 square roots of 3, and this would be in centimeters. And we're done.